Hi girls, in this lesson I want you to do a little bit of extra practice in writing formulae, just as a bit of recap on the work we were doing before half term and for a little bit of extra practice. So in this exercise you're going to be practicing a mixture of simple ionic compounds and those involving molecular ions. So let's just do a quick recap on that. So for the simple ionic compounds, that will just contain two elements from the periodic table. So that might be something like magnesium oxide. So you would use the magnesium symbol and its valency and the oxygen symbol and its valency to get your formula. It might even be something like potassium chloride. And again, you would use just those simple elements and their valencies. Remember, in general, if it's an element from the front of your periodic table, if it's in a group, you can get the valency from the group number. The valency of group 1 is 1, valency of group 2 is 2, then 3, 4, and then we start to count down again, 3, 2, 1. For this block of elements in the centre, those are our transition metals and they don't have a group number, so we can't get the valency that way. So either you'll be given a number in brackets, for example III, it'll be in Roman numerals, and that would be a valency of 3. Or for some of the elements like zinc, copper and silver, the valency is given to you on the back of your periodic table. Make sure you have your periodic table out in front of you, and let's have a look at the back of the periodic table. So as I said, for some of those elements, the valency will be on the back. So if I zoom into this positive ion section, you can see we have a few of those transition metals. So here we've got copper, tends to be copper 2+, and iron you can see can be a couple of different valencies. Lead tends to be lead 2+, which means it has a valency of 2. Silver, there's no number in brackets here, but you can see from the charge that the valency is going to be 1. And zinc, you can see from the charge the valency is going to be 2. So if it's a transition metal and you're not given a number in brackets, then check the back of the periodic table and see if you are given the valency there. But what you're also going to be doing today is mixing those examples with some that involve molecular ions. And those tend to be over here in the negative ion section. There's one, if I just scroll back, that's in the positive ions, your ammonium. So that's a molecular ion. Remember, a molecular ion is simply an ion that contains more than one atom. So you can see in ammonium, we have 1 nitrogen and we have 4 hydrogens. So that makes it a molecule in that it contains more than one atom, and then it's an ion because it has a charge. But most of our molecular ions that we'll be using are over in these negative ions. And it's worth, as I said in your instructions document, being really familiar with the molecular ions, just so that you're not mixing them up with other simple ions. The most common ones, and you don't have to learn the formulas because they will be given to you in the exam on the back of your periodic table, but the most common ones in fourth form to be used are carbonate, hydroxide, nitrate, sulfate, and sorry I missed one, hydrogen carbonate. Those are the most common ones to be given to you to use in fourth form. But it's worthwhile being familiar with those names so that you're not getting confused, because there is a difference between sulfate, sulfite and sulfide, and that all sounds very confusing. Sulfite is not used that often, but if we look very quickly at the difference between sulfide and sulfate. So sulfide is just a sulfur atom that has become an ion, so it only contains sulfur. And if we look, sulfur is in group 2, so it will form an ion of a charge 2-. But sulfate, that ATE part at the end, means that it contains sulfur and oxygen. The ATE means contains oxygen as well. And you can see here from the back of your periodic table, sulfate is SO4 2-. And when you're writing the formula, you need to be really careful what you use here. In the formula, you use the letters and the numbers at the bottom. So you need to use SO4. then what do you use the charge for? Because you don't include that in the formula, but you use that for the valency. I'll just put V for valency here. So that is what you use for the valency. So be really careful with these, and it helps to be familiar with your molecular ions, so that you know that, well, carbonate is not just carbon, it's carbon and oxygen. Nitrate is nitrogen and oxygen. Sulfate, as we've already looked at. Hydrogen carbonate is actually hydrogen, carbon and oxygen. The only one that's a wee bit different is hydroxide. That's hydrogen and oxygen. Okay, it's the one that ends in IDE. That's kind of an exception to the rule, but it's OH minus. So be familiar with those names so that you know to do it that way for those examples. Okay, so let's look at a couple of examples of your simple ionic compounds and those containing molecular ions, just to recap on how to do this and how to write formula. If you're confident enough, you can just start on ahead at the worksheet, but this could be a good helpful recap, and I'll try to be as quick as I can. So let's take magnesium oxide, for example. Please have your periodic table out in front of you. I'm not going to flick back and forward to the periodic table, so have it out in front of you. If you don't have it there, pause this video and get it, and then play it again. So first of all, decide what type of compound that you have here. This one is simple. And what we mean by it being a simple ionic compound is that it just contains two elements. Oxide is not a molecular ion, it just contains oxygen, it doesn't contain anything else. So this is just a simple one. So if we have a look at magnesium, we just write down its symbol at this point, which is Mg, and oxide is just oxygen that has become an ion, so its symbol is O. Okay, what we need next is the valencies, and we get those from the group numbers in this case. So have a look, check to see if it's part of a group. If it's not, you either need to check the back or use the valency given to you in brackets. But magnesium is in group 2, that means it has a valency of 2. Oxygen is in group 6, have a look at your periodic table. The valency associated with group 6 is 2. What I ask myself at this point is, can I cancel down those valencies? Is there a number that I can divide both of those numbers by to make this a simpler ratio? So the ratio at the minute is 2 to 2. If I divide those both by 2, I get a ratio of 1 to 1. Okay, then what I do is I swap and drop when they're in their simplest ratio. And what I would get there, although you can kind of skip this stage if you're happy enough, I would get Mg101, and at this point we write our formula close together, no gaps between it, and we drop our numbers down to the bottom and we remove those circles. But what we learnt before half term is that you can ignore ones in formulas. So if you think of the formula of water, it's not H2O1, it's just H2O. Where there's no number after an element, we just assume that there's only one of it. So that would be a formula of MgO. And that is your final answer. So this is a really important stage that sometimes we forget, to cancel down the valencies if possible. Let me just do one other simple ionic compound with you quickly. Again, check it's usually the second name that's going to be your molecular ion if it's there. But chloride is just IDE, so that means it's a simple ion. It's just chlorine that has become chloride. So it's not one of our molecular ions. If you're not sure, look at the back of your periodic table. If it's not on that molecular ion list, then you know it's a simple ion. Okay, in this example, copper is in that transition metal block, so therefore it doesn't have a group number, so it doesn't have a valency associated with it. So this is just copper, Cu, with a valency of 2. Chloride is just chlorine that has become an ion, so it's Cl, and chlorine is in group 7, so it has a valency of 1 associated with it. Ask yourself at this point, can I cancel those down? And no, I can't. Really, when you have a valency of 1, you're not going to be able to cancel it down because you can't divide that by anything. So what I do at this point is I swap and drop, swap the valencies and drop them down. So you would get Cu1, Cl2. 2. And remember to write that formula squished together, no gaps with it. And then what we can do at this point is ignore our 1s. If you're happy enough, you can do that at the swap and drop stage, but that would give you a final formula of CuCl2. Okay, let's do an example that contains a molecular ion. So here we've got calcium sulfate. So we can tell by the end of the name ATE that this contains oxygen as well. So it contains sulfur and oxygen. So look to the back of the periodic table. That's written as SO4 2-. So let's go step by step through this. So calcium is Ca. It's in group 2, so it has a valency of 2. Sulfate, as we said, is SO4 2-. At this stage, what I want to do is I want to write down the formula. That's everything except the charge. Everything except the charge. So I write down SO4. Don't forget that little 4 at the end. Sometimes people leave that out and forget about it. Then what I want to do is work out my valency. And remember, the valency of an ion is equal to the charge, just without the plus or minus. And so in this case, it's going to be 2. So at this stage, which is really important with these ones, is that you cancel this down if possible. So you can see my ratio at the minute is 2 to 2. And just as we did before, I can divide both of those by 2 and get a ratio of 1 to 1. Okay, now with these examples, it's easier to do your swap and drop and ignore the 1s at the same time. Because if you're just swapping a 1 down to your molecular ion, then you don't need to use brackets. So in this case, I don't need to use brackets. And so the final formula is just Ca. I'm swapping a 1 down, but I don't need to include that in the end. And then SO4. And again, write that squished together. So as I said, if you're swapping down a 1 to your molecular ion, you don't need to use brackets. But let's look at one final example where you will need to use brackets. So again, look at your name and decide, is this a simple or one that involves a molecular ion? Because you end in ATE, this is not sulfide, it's sulfate. So that means it's your molecular ion from the back, which is SO4 2-. So be careful with that. Let's write down our formula and our valencies. So we've got aluminium with a valency of 3. We've got sulfate, which again, write down your formula first of all, which is SO4. Then use the charge for the valency. So it's 2 steps to that, okay? So SO4 is the formula. 2 we use for the valency. And notice how I haven't put the 2- in the formula. Okay, ask yourself, can I cancel this down? Well, I can't, because if I divided them both by 2, I would get 1.5 with my aluminium, which you can't have. So this I just leave as it is. So I'm at my swap and drop stage, but you can see that I'm swapping down a number greater than 1. So I can't ignore that. So what I will need to do in this case is use brackets. Those brackets go around the whole molecular ion. So the S, the O and the 4 all need to be inside the brackets. And how would you write your final formula? Well, we write it down Al2, then open up your brackets, but keep it close, remember. SO4, close your brackets, and then the little 3 that is swapped down from the aluminium. So have a look at the colour coding of that and see that you understand where each of those numbers came from. So the aluminium is your symbol of, Al is your symbol for aluminium. 2 came down from the valency of your sulfate. Then we put the sulfate formula in brackets, the SO4 in brackets. And then that 3 came from the aluminium. So be careful with those examples that involve brackets. So what I would like you to do now is, and you can just pause the video and use the examples from the screen, or this worksheet is in your file section of Teams. I've given you a few examples of some mixed compounds, so ones that are simple and ones that contain a molecular ion. So each time, and you can read the little introduction from the worksheet, but in each example, first of all, ask yourself, is this simple or is this a molecular ion? So you can see here lithium oxide, and that is just simple. So that's just going to be lithium and oxygen. Magnesium nitrate, that involves your molecular ion, so you're going to potentially have to use brackets, use that formula from the back of the periodic table and so on, so be a bit more careful with those ones. So just remember those key steps. With the valencies, be careful that you choose the right valency, make sure you cancel them down before you swap and drop. With the molecular ones, don't use brackets if you're swapping down a 1. Do use brackets if you're swapping down a number greater than 1. So what I'd like you to do is to complete this on file paper. As it says in the introduction of the worksheet, please read that carefully. For each example, please write out the name. So you'll write number 1, lithium oxide. So when you look back, you'll know what this formula was for. Then do your working out and then write your final formula. That's what I should see for each example. And I know this looks like a lot of examples, but hopefully you're familiar with these from before half term. You need as much practice in this as you possibly can so that this comes really easily when we come to writing equations. Try these 30 examples. And then please upload your answers as a Word document to the assignment on Teams. Try to do that by the end of the lesson, just so that it's done and out of the way, as we're doing something a little bit different next week. We're taking a break from formula. So aim to have it done by the end of the lesson, or certainly by Monday morning at the very latest.